Day 68, page 272, rotational kinematics, problem 53. So here we have a bike tire and we got some funky units. Well, I mean, they're English units. And it says, ignore the contribution of the spokes. We're just taking all the weight, all the mass of the bike tire to be on its outer rim so that the format or the equation for rotational inertia will be mr squared because we have all the mass at the same radius, the radius of the tire, 13 inches, from the center of the tire. So over here I have the tire, 13-inch radius, 26-inch diameter. And let's watch what happens with the units here. I'm not going to ignore them, but let's watch what I do. So net torque, and we're assuming no resistive or frictional torque. There's only one torque that's causing the acceleration here. And so the torque net is equal to the rotational inertia times the rotational acceleration. It's just like F net equals ma for linear motion. Well, I is mr squared, so I just plugged in mr squared for rotational inertia. And I'm not given mass in this problem, but I'm given the weight of the tire and the rim. So back over here to the right, weight is equal to mg. This works in any units, but we usually use SI units. But mass is weight over gravitational acceleration. So I'm plugging that in. I'm plugging this in for mass. So getting rid of the mass, and I have W over G. All right. Then I'm going to take this whole equation right here and solve for alpha. So alpha then is equal to torque net times G over omega r squared. So you can check that all out. That works out. And I'm given torque net, and watch, now I'm going to be really careful with the units. The torque that's given is in English 50 foot-pounds. We're used to 9.8 meters per second squared, but if you look over to the left here, 9.8 meters converts to 32 feet per second squared. And then I'm leaving the weight in pounds down here at the bottom, 3.22 pounds, and then I converted the radius in inches up here, 13 inches is 1.08 feet. And the reason I did that is if you look at this, excuse me, you're going to see that the pounds are going to cancel out. So we never had to make a conversion into newtons. And I got everything in feet. So downstairs, you're going to get feet squared over here because you're going to square this, you can get feet squared. But you have feet there, and I'm going to change this 9.8 to a 32 feet. So I'm going to have feet squared upstairs, so the feet will cancel out. And all you get left is the second squared. Technically, radians are not a unit, but that will be the rotational expression we'll have for the angle, radians. So you'll see that everything works out to second squared, so we're good. We never had to make any real difficult conversions into SI. You could do it that way, but as you can see here, all the units cancel out real nice if we were a little bit careful with the units, making everything feet and so forth. So if you just plug everything in, you get alpha is 426 radians per second squared. That's a pretty good acceleration.